Hi Luis, how you been? It's been a long time. How you been doing good in all your classes? I feel like I'm Pio for computer science again. You bring me way to 2023. Okay, so I wanted to create a little video for you so I can explain the time complexities better because I feel like this is way easier than by chat. So pretty much I just created several functions so we can go over their time complexity, and we're gonna go from like very easy to harder ones to your programming. So we're gonna start off with the simple print list function. I'm pretty sure you know this, but we're gonna go from baby to more harder. So pretty much our print list function runs in on time because the function uses a loop that iterates over each element in vector x. And this is how I like to remember it. Like if it touches every element in our vector or array or whatever we're using, it's automatically on. Our second function is a locate smallest function, and our time complexity is also on for the same reason that our for loop iterates through every element in our vector, because it compares every element to find our smallest. So we also have a selection sort algorithm, and I'm sure you know this one because we covered it with Dittrich. Remember? Well, we have this one, and our ON time, or big O running time is O to n to the power of 2. This is because for the for loop, as mentioned before, it iterates through every element in the vector x. So that's why it's on. The second one is also on because we obtain the smallest location of our number or of our integer in the vector, and then we have our small one over here, right? And then we compare it with every other element in the array, which has to touch every single one as well. So it's O to N. Since we find the smallest, we have to check every element to see which one is the smallest. So it's also ON. And our swap is just in constant time. So you multiply all of them and it gives us O to the power of N2. O(n) to the power of 2, I mean. So now we have more examples over here, and we have our function A. So for our function A, we have two separate nested functions. This is 1 and this is 2. So we're going to start off with their first nested function. So we have iterates through I to n, j to n, k to n. So each of the for loops run in on time because it runs through every element. And we have our increment is constant time. So what would be our time complexity for the first nested for loop? It would be O to the power of, why do I say O to the power of? I mean O n to the power of 3 because we have 3. 1, 2, 3. So now we're going to move on to our second nested for loop. So we have I to n, j to n. Each of them is also n. And this would be constant time or increment. So what would be our time complexity? It would be O n to the power of 2. Okay, so you see how we have n to the power of 3 in the first one and O to the power of 2. What would, I already have the time complexity there. But what would be the time complexity without looking at my answer? What would be the time complexity? It would be O n to the power of 3. Why? Because when we have a function that has several nested for loops, we don't multiply them together. We actually get the time complexity of the for loop or that has the highest or worst time complexity, as you can say. So our time complexity would be n3, since O n3 overrides O n2. Therefore, our time complexity is O n3. So now we have a function b. So easy, right? I to n, it's O n. The second one, you see, we have over here this. Every time I see j equals j divided by 2 or I equals I divided by 2, I automatically think log n. How they taught it to me when I was an undergrad, they would tell me, just imagine you have a log, right? And you're actually cutting the log in half every time. So you have a log, cut it, and then we get that little piece and cut it every time. This is exactly how this works as well, except we have j. So that's how I like to remember it. But of course, best practice would be to get a user input and calculate the steps and see how you can, how the program works, okay? But just a little cheat sheet. I like to, every time I see j equals j equals j divided by 2 or something divided by 2, I automatically think of log n. So what would be the overall time complexity of this? It would be this times this equals O, big O, and log n. So this would be our time complexity for our function b. So now we have your program. So this one's more complicated. So we have, let's start with an outer loop. Easy, right? That's what we've been talking the whole time in this video, right? The outer loop runs in n iterations because I goes through every element in n. So we get O n. Now the inner loop is more complicated. Or let's pretend we're actually going through the program. Our first iteration is at j equals 1. Of course, we're here. We start here, right? So, okay. It is going to run again. It's going to run one time. Now, for right now, right? We're going through it. Now, we're going to go to our second iteration. We're going to do again. So, because j is now n, j equals n because of this, or the first iteration that we went. So, okay, we're in the first one, right? And then let's go back to the first one. Let me explain. So our first iteration is this times n. We're at j equals 1, and then j is 1, so 1 over here times n. So therefore, by the second iteration, our j equals n. Since 1 times n equals n. So that's why our j equals n. Now the program will attempt to move to the next iteration, but remember our program is at j equals n over here, right? J equals n right now, since we did this whole operation over here, which is equivalent to the termination condition. J, this terminal condition. Because by the second iteration, we're trying to do the same thing. Let me do it over here. We're in the second iteration. Our j is n right now. Of course, because we got it from over here, right? We did this in the first, let me put first iteration. Second iteration, our j is n, right? We get it from the first one. Our j ended up being n. So we try to iterate the second time to go to the third one, and it's n equals n times n. Because our j turned into n, and we had to go through this again. So this was j, j, n. I'm going to repeat it again. J, j, n. Because our j, we got our j from here. And this is what I'm trying to put over here. So what does that mean? It means it was equivalent to the termination condition because our j equals n times 2 right now, or n, or j equals n times n, which is literally the condition over here. Therefore, it terminates there. Therefore, not executing a third time. Therefore, our inner loop runs up to 2 iterations, therefore running on constant time. So now we know that this runs in constant time. So we get on for the first and O1 constant time for the second. Now we multiply them together, and our overall time complexity is O(n). And I think I put the function c twice. Let me delete. So I hope you understood by my explanations a little bit better. Let me know if you have any more questions. Send them to me via Discord. I hope you have a great rest of your semester. Bye.